Hello, I'm Shane in Sweden, and this is the second part of our presentation on insecure deserialization threats from the OWASP top 10 list. In the last video, we looked at the background to the problem, and in this video, we're going to look at some C# code examples that we can use to illustrate exactly how this problem arises and what we can do about it. In the next part, part number 3, we'll actually look at general principles and general rules and guidance for how we deal with insecure deserialization. But in this video, we're going to focus on a bit of coding. Okay, so let's get stuck in. Oh, and by the way, there is a link to the C# solution that I use in this project if you want to download it and work through the code yourself at the same time as watching the video, feel free. Okay, so the example we're going to look at today, we want some method of reporting problems and usage patterns and stuff from our web application in the client. So we're going to create a REST service that we can use to report on problems and usage patterns from the user. So we'll start off by creating a REST service, and this will have a post method that we can send our reports to. And so that the user, when our application, which is running on the client on a web browser, it can call this web service and post, for example, exception information. That'll be a good one, client-side error reports, but not just error reports. It'll also want to perhaps post information on how we use the application, different web pages that people go through, sort of Google statistics, and maybe even timing information and general UX information so that we can use to make a better application. Okay, so we want a generic post method that can accept different types of reports from our client. Okay, so we have to be able to handle several different types. So this is the basic background problem that we're trying to create, a solution, and it'll involve serialization and deserialization, and we'll see what problems arise. Okay, so we're going to go into Visual Studio, and I'm running Visual Studio 2016 here, and we're going to start a new project. And we're going to create a .NET Core web application, which will provide our services that we're going to use here. So we just have to save this to the good folder. Now you could, of course, use a standard MVC application, standard .NET, but in this case, we're going to use Core. And so we'll call this application our error reporting services. Okay, and Visual Studio gives a choice here. We're going to choose a web and API because we're creating services. Okay, so we have our basic application, and as always, it's always good to just run it and see that it's okay. And also, when we run the program, we'll find out what we have for port information. So we can see it's 62362 is the port that our application is going to run on. And the application returns the standard values. I assume this is some sort of default get. So if we go into the solution, we can check our value controller, and there you can see the basic get returns value 1, value 2, exactly as we saw. Now we can copy our URL here and use this in a SOAP UI type test client. We're going to use Postman here. We can copy and paste in these values, and then we can run our get again just to check that we're able to call our service from an external client. We'll do it with the value 5 here, so it should go to the get, yes, and it goes to the get method, which has an integer variable. Okay, so we're able to run our service from our Postman client, our REST client, and debug and see what happens. Next, we want to add a test project. So we just need to stop this up and add a test project to our solution so that we can run unit tests. And here we're going to add an XUnit test project. It doesn't really matter which unit test type you have, XUnit, MSTest, NUnit. They're all pretty similar. We're going to call this error report our reporting services test. Now we need to do a little work on our tests here. We need to rename them and add a reference to our main project. Right, so let's just do that so we can get on with it. So let's rename this to reporting services tests. And the class is renamed. Yep. Okay, let's create a default unit test just to check that everything's working. We'll call the test it's based around the reporting service, of course, and we'll do the default get method, and it should return some values. So we should create an instance of the controller, because it's the controller we'll be running our test against, and we can create that as a new controller. And we should probably adjust our usings here so that we don't have to have these long namespaces. Just take that out and put it up here with the usings. Okay, and we can remove this, which is good. Okay, so we've created our controller, and we should really be using our formal pattern, which is arrange, act, and assert. Okay, so in our arrangement, we create our controller. In our act, we call the get method, which will return some result. I think the default get returns text. We can probably check that, see what actually is returned. Yeah, it returns, well, we can see it returns, get returns tuple, and the get with an integer returns the text value. So we can actually change that. So we'll call it with the integer variable, and that should return the text value. So we just need to create our assert, and expected value is value, string, against our result. Right, and we now have our first test. We can just set a breakpoint on that, and actually we can debug our test. Okay, and we can come to our first breakpoint. So now we can go actually into the call, yes, and then it returns the value. We get a result, and the test passed. So we have completed our first test, and we've seen that everything is connected properly between our test project and our services project. So let's create a new test. We copy and paste from the old, because really we're interested in, much more interested in the post method than the get method. So let's create a post test. And actually we should also check that that we can post from our external client, not just through unit tests internally against the controller. So if we take our postman and we change the type to post, and then we want to get rid of the values, and we need to get this running, so we need to comment out that so we can build our solution and get the service running. Okay, it's running, so now we can set our breakpoints there, and now we can send our post. And we're getting an error here which says unsupported media type, right? Because we haven't told it that we're sending it. It's expecting JSON data. So let's post some text. We can put that into the body, and we'll just send some basic text like hello. It's not even hello world. Set the type to JSON. And if we go into the solution again, then we can capture this hello value that we're sending. And we can set a breakpoint there and start the service running again. Now we need to inform the server that we're sending JSON content. So we should change our content type header. And now we can send And here it's come into the controller. Okay, so we can improve our test a bit now, and we're actually going to send a real value, a real exception. So we create a new exception here, just generic exception with some sort of a text message. Something bad has happened, and now we need to serialize this exception object into a JSON string. So we're going to call on the JSON serializer, and we will serialize our error. Now, the result that we'll get back from our serialization should be a string, which we can call our exception JSON string, JSON data. And now we can actually, under the act, we can do our post. And now we're actually going to post the real JSON data. And we don't need an assert statement at the moment. We're just going to run a smoke test to see that our JSON data arrives on the back end. So if we set a breakpoint and debug our unit test. So the test is running, and we create, you can see we created the serialized data, which we then post. And we are indeed coming into the controller, and we've posted the text. So that's a good start. Now, when we're doing our post, we want to post something. This should be in a manager class or a manager assembly. So we'll create a new project for our business logic, which we can call managers. And we'll need to rename some stuff here. So we'll create our first manager class, which is an error manager. Let's rename that. And so now in our test, or in our controller, we can create our posted object by deserializing with the JSON deserializer the JSON string we get in from the controller. So let's deserialize that object, which should be a value. Now you notice we're not converting directly to an exception because this service has to take, or it's designed to take, several different types of objects. So now, but we can cast our deserialized objects to an exception in this case. We can worry about switch handling later on. And we need a reference to our managers, of course, if we're going to call one of the manager methods. And so we'll call our error manager, and we'll create a new method which will persist the exception, the error report we've received. Now, if we need to create that method on the manager class, and we need to go into the method, find and get rid of the throw not implemented exception, otherwise the program will stop there. And we'll come back later and do something about persisting. So we have our report, our test, which will generate real exception data, serialize it, post it to the controller. And you can see the JSON data down there. Let's just move this so you can see better. We come into the controller, and we have our posted object. Now, if we look at what that posted object, the deserialized object is on the controller, you can see that it's not an exception. And if we get the type, we can see that it's actually not exception. Instead, it's a JSON object. And of course, when we cast it then to an exception, the error is null. So we have failed in our deserialization. So we have to ask ourselves, why is the deserializer not being able to convert it to an exception? Well, the reason is because it doesn't know what type to do. And we actually need to add in type name handling here. So the deserializer will know which type to handle, and the type information must come inside the JSON data we send. So we need to change the settings on our deserializer and our serializer. So we're going to create JSON settings, JSON deserializing settings here. But perhaps before we introduce type name handling, we should grab a copy of how the JSON payload looks like right now, so we can compare it and see what the difference is after we introduced type name handling. So if we debug our unit test here, and we come down to where we serialize the data, and then we can grab a copy of our serialized JSON payload and paste it into our text editor so we have a copy for the future to compare. And you can see it's an exception type JSON payload. So if we stop debugging our test and now we add in our serializer, JSON serializer settings. Now there are many settings we can set here, but in this case we're only interested in changing the default type name handling. So we're going to set the type name handling, which is the default setting is none, which is the safe setting. We're going to change it now to all. Okay, and of course we need to, when we serialize our object, we need to use those settings. So now if we debug our test again, we can see what the JSON payload looks like now. So we come down to our serialization and we can copy that data, copy the value, and also paste that into our text editor. Now the change is at the beginning, so if we just move this top line so that we can see where they're the same. And you can see the difference really is that we have this type, $type variable, which describes the object that we have deserialized and we are transmitting over the wire. Now we need to also introduce the same type name handling when we deserialize. So if we go to our post method in the controller, and here we need to introduce JSON serializer settings as well, and also the deserializer uses those settings. So if we run our debug test one time more, so we can step through the process. And here we come to the post. So we come in and the settings are set and we deserialize it. And you can see right away the deserializer knows that this is a system exception. And if we do the get type, just to confirm, there you can see system exception. So now we are transmitting our exception, but the system has a potential for handling other methods. And you can see when we go to the persist error, there's no error generated because we have an exception we're passing. So we have a system that can handle exceptions, but also other types potentially in the future. Now, since we are interested in remote code executions, before we do any more tests, it's useful if we can run the same payload that we've just generated from our Postman client to make sure that this is we get the same behavior when we actually do it over the net instead of doing it inside a unit test. So we can send our JSON payload, and you can see it's come into the controller, except this time it's going over the wire. And you can see when we do the deserialization, we have indeed been able to send an exception object over the wire. So the question is, what else can we send over the wire? Well, here we have a security blog by Peter Stuckley, and he's talking about insecure deserialization. And he actually shows here a rogue, a bad JSON payload, which is actually just sending some file info class, .NET file info class. And we're going to use this to see if we can have some fun with our system. Now, his class is based on a C# object called object, which has a file name, file info as a sub property, which is not exactly what we want. We just want to send a file info, so we'll have to adapt this payload a little bit. That doesn't require too much effort. Now the payloads I'm using here that we're sending over the wire, I'll include it in the solution, so you can try these out yourself. Now we have our payloads. We can create a new request in our Postman. And in this one, we're going to post a file info object. Now this actually is remote code execution exploit. So this is actually a gadget we're sending that's been discovered. Okay, so we need to change the Postman settings. We want this to be a post. We want to post in our payload. We want to be sending JSON payload. And we need to copy in our URL. Right, now, as you can see from the other payload, we need to comment or escape our double quotes. So we'll have to do that here for the payload, which is a bit boring, so we'll just do this very quickly. Yep. Now, the file that they had in his, Peter had in his blog was RCE test, but we want to do something more interesting, so we're going to do web config, but we don't want to crash our application, so we'll change it so that one letter, so it's not the real web config, it's a web config. Because what this gadget does in remote execution is converts the file to be a read-only file. So we're going to add a web config file to our project. So we'll just add a text file. And we'll call it web config. It doesn't have to have any content. But if we look at that file in Windows Explorer, you can see that the read-only flag is not set. Okay. So if we start running our service so that we can send the payload to it, and then we go to, and we come into the controller, and now you can see that the payload is a file info payload. But because we've got type name handling auto, it'll read that type from the file, and you can see it's created a file info, and you can see the read-only flag is set to true. So the execution has already happened. Now if we go to our file properties again in Windows File Explorer and look at the file properties now, you can see this read-only. So here we've actually created a remote code execution. Now this is a pretty serious attack, since you can imagine there are many files that if we lock make a read-only. For example, the log file that an SQL Server database is writing to, then the actual application will crash, and we've actually created the possibility of a denial of service attack here. Although of course there were a number of factors that had to be in place here for this attack to work. The file had to exist, and we had to know the name of the file and its location. The server had to be running this type of serialization with this type of name handling, and be accepting objects that from untrusted data sources to allow this actual attack to occur. But having said that, it's quite clear also this is quite a serious attack. It is quite doable. Okay, so we have this problem in our deserialization. The question is, what do we do about it? Well, one thing we could do is we could have a control on the type after deserialization. So we can check if our posted object, now that we deserialize it, is actually an exception before we persist it to prevent, for example, unhandled errors. This won't, unfortunately, help us with regard to the actual security flaw, because like many objects, the execution actually occurs within the deserialization process. But still, it's useful to have this control for it. If we're persisting in a number of different types of objects, we probably want to make sure that we're actually persisting in our data stores only the type of object we are expecting. And much more importantly, it's very important that whenever we detect something that happens with deserialization where we're generating objects that we weren't expecting, that we throw an exception and that we also log those exceptions, because it's a good sign that there may be a potentially serious insecure deserialization problem. So this is actually quite useful, even though it will not help us in preventing the actual remote code execution. So we're going to paste this in again, and now if we run our post from Postman again, but first we should just check actually that we've reset our file, so it still is, yes, it still is read and write. And we get our service running. And we post. And we come in, and as you can see, the execution has already happened. Now, although we've captured the problem, unfortunately, yeah, here we can see there's no exception. If we go to our file, it's too late. As we said, the file has now been, property has been set to read-only. So this, while a very useful thing to do, this guard code, it doesn't really help us. We need a better method of protecting our deserializations. But logging still is important, so we're going to use our error manager to actually report. The error manager was expecting, we were expecting some sort of exception object, and we found something else. So let's report that and log it. And we probably have maybe it would post an alarm to Splunk or some other centralized system so that we can keep track of our serialization errors. Okay, so what can we do to actually protect our deserialization to make sure that it works properly? Since this sort of object control is obviously ineffective in preventing the remote code execution attack. Well, we can go, we can actually do an explicit. If we give up the idea of taking different types of objects in through our post, and we just create a service which is just for deserializing exception objects, we can reduce the risk. And in that case, we can set our type name handling to a safe setting, which is none, and in fact is the default setting. So we can set that explicitly to none, and we're expecting here right in the deserialization that it's going to be an exception type. And in fact, we could probably do this at the from body deserialization. So if we go to our payload here and we send an exception from Postman, we can see that the JSON payload comes in and the conversion takes place right away, because now the deserializer knows exactly which type it's supposed to be converting. And we don't have any problems. We're able to post and persist our exception information. Unfortunately, our service now, we can only post exceptions. We can't post any other type of object. Okay. However, if we try to execute our remote code execution attack now using our file info object, you can see that it comes into the controller. And at the moment, our file is in a writable state. And when we try to deserialize our file info object now, we get an exception. And so the deserialization never happened, and so the file is still in a read-only, or still in a writable state. So we've protected ourselves. So are we effectively safe then from a remote code execution attack? Unfortunately, we're not really. And the problem is to do with polymorphism in object-oriented languages. So for example, our service accepts exception types. And here is a validation exception, which comes with system component model data annotations. And if we look at this validation exception class, it inherits from the type exception. Okay. And when we go down to where the properties are in this object, we can see that it has a value property which can hold an object. It can hold any type of object, including, for example, our file info object. Now, it doesn't have a setter on that object, luckily enough, but you can still, but it should still be possible to create a validation exception object with a file info object in its value property. So we're just going to see if we can send, what happens if we try to send a validation exception object through to our controller? Does it accept it or does it not accept it? And this is where we have a problem. There are many objects, many .NET types, native .NET types that have these dangerous possibilities inside them. Not all of them have been discovered. So we're going to just add a using here for system component model data annotations in our unit test project, and we're now going to create a validation exception instead of our exception we had before. And remember, this validation exception inherits from the exception type. So we can set a breakpoint, and now if we run our test and send a validation exception type to the controller, let's see what happens. When we come into the test, create our type, create our payload, and you can see that the payload here is a validation exception, and now we're into the controller, and the serialization motor does not generate any exception. And you can see we have actually deserialized here a validation exception, which can have an object as a value, and that object could have been a file info object, which was now deserialized and executed the read-only property on our file again. And you can see that the object is still considered to be an exception, and we haven't created any errors. So this method has not protected us in any way actually from remote code execution attacks by limiting our service to just specifically exception types. A much better answer is to use a custom serializer binder, and so we're going to add a new class here. We'll call this a whitelist serialization binder. And this we can add to our serializing and deserializing motors so that they are tied to specific types. Now we're going to make this sealed so that it can't be adjusted afterwards, and this will inherit from the serialization binder class. Wait, actually, wrong, it used to, but now it must implement the iSerialization binder interface. The old method was the serialization binder. So we have two methods, and we need to obviously have a list of our types that we want to allow. So we can just create a list of tuples here with their name and their type. And we can call this our whitelist. And these are the types that we will actually allow the serialization motor to deserialize. So in the constructor, we need to initialize this list. And we can add our exception, system exception, as one of the types that we want to allow. So we can add a new tuple here for that. And the type is system exception, obviously. Just want to check and make sure that we have the right spelling, because this thing is quite fussy. And it will be, of course, type of exception. Okay, so we have created our whitelist here, which is a very simple whitelist, but this would allow us the possibility of using our same post method in our service to receive other types in the future. We just need to add them to our whitelist. We're not going to bother with the bind name method here. We're just going to implement the bind type. And so when we receive, every time something's deserialized, it will come to this method, and we can check. And we'll check if the type exists in our whitelisted types. So if we go through each of the whitelisted types. So for each tuple in our whitelisted types, if the type, that'd be tuple item 1, which is the name, if that's equal to our type name, then we can actually return the type, which is tuple item 2. Right, and we'll go through each of the types, and if we don't actually find the type on our whitelist, then we would, as always, we want to throw an exception. We must throw an exception. If we return back just a null, that there is the possibility that we might fall back on some default binder, which would allow the type to be deserialized. So you want to actually always throw an exception when something goes wrong with the types. So we just create a message here for our log, attempt to serialize a legal type. And this is the basic implementation we need for our custom serialization binder. And we could, for logging purposes, we could add the type name. Now we've created here the possibility of a injection attack. If the type name information that came here when someone included, like for example, a script, which was then persisted to the database and somebody reads the log through a web browser later on. So To prevent this, we should really make this text safe, and we can do that using the HTML encoding, which in this project is under Web Utilities in .NET Core. So now we have encoded the text to make sure that there's no possibility of an injection attack, and we can safely log our type information when something goes wrong. So this is an okay start implementation. We should actually verify our types here as well, which we haven't done. And now that we've created our whitelist serialization binder, we can add that to our deserialization motor through the serialization settings. So we can set the serialization binder in our settings to a new instance of our custom white serialization binder, which will allow only our types. And while it still is better to have our type handling none, we can actually test this here. We can use, or we can take the freedom now of having an all, although again, I do not recommend it. And so we can use our settings in our deserializing stage again. And we can start our service, and we can see what effects now we have when we have a custom serialization binder. Because potentially now that type name handling is set to all, we could possibly send through dangerous objects. So if we go to our file info, we should set a breakpoint first. So if we send our file info object and we come to our serialization, okay, so we come to our automatically to our bind type method. Now the type here should be file info. You can see it's system.io.file info, which is not in our list. So when we go through the list here, it should generate an exception. And indeed, that's exactly what happens. Generates an exception here in our binder. And we can see we've got an out of range exception. And if we look at the details, we should be able to see our custom message, attempt to serialize an illegal system.io.file info. Now this generates an exception in the serialization motor. So our file info is safe. There was no deserialization occurred. What happens when we post an actual exception? Well, we come into our controller. We come into our bind type method again. But now the type is an exception, so it's allowed. And we're able to fetch our exception information and persist it, which is exactly what we're hoping for. Okay, so we can handle file info, we can handle exception. How do we handle our validation exception that we had before? Problem. Well, if we go back to our unit test now, and we debug it. So if we run this, we're creating our validation exception data. As you can see there, the type is a validation exception with type name handling. And we post that to our controller. And when we come into the controller, we'll come to our custom binder. Now the type we have here is validation exception. So when it goes through the list, looking to see if we can find that on the list, it doesn't. And it throws our out of range exception, plus our custom log message is there. So now we finally have a deserializing motor that can handle different types, but we can restrict which types we actually allow it to deserialize an instance. And with this solution, if in the future we want to expand the types we can deserialize, we just simply need to go into our whitelist serialization binder. And there we can add to the capabilities of our system. I hope I've demonstrated through these examples that it's not always easy to handle insecure deserialization. Often we're not aware of the potential dangers in the operations we're carrying out. And unfortunately, new gadgets are still being discovered, so there are potentially a large range of objects that are unfortunately simply not known yet. Before we go, I'd like to show you one more code example which quite dramatically demonstrates the type of code execution that can take place when we're dealing with insecure deserialization. Now, as we saw, we can only really deserialize types that the system knows about, and some types are clearly more dangerous than others. One particular problem is the object data provider, because the object data provider actually allows arbitrary execution methods on it, and is used quite often, for example, in Windows Presentation Foundation applications. So if we can have an insecure deserialization of an object data provider JSON payload, then we can pretty much do anything we would like to. Now in this application, we have a Windows Presentation WPF browser application. And in our tests, you can see we're going to send in an object which will then be deserialized and persisted, more or less, quite similar to what we did in the previous example. And this is the type of object we're sending in. We're sending in a mutual fund description, what the fund contains in terms of shares and companies and so on. And so if we go to our test, and we're going to deserialize, run our test here, which is deserialize non-dangerous object. If we debug this test. So we're creating our browser utilities. And we're going to store our data objects, which in this case is our payload of a mutual fund description. And so we come to the store object method, and the first thing we do, as we've seen before, we have this dangerous type name handling, and we're going to convert our mutual fund object. We check if the fund is a mutual fund, which it is, and then we persist it. So that's fine. But what happens if we generate, or if we use a dangerous payload, which in this case is our object data provider? And as we said, we can carry out an arbitrary execution on this. What happens if we send this packet in through the same deserialization? Well, let's go to our second method here, which is we can deserialize a dangerous object to show that bad things can happen. And if we debug this test, we come down to our same store data object method, and we deserialize our object, and we can see that the calculator method is executed on our machine. That's another example of what can happen when you've got insecure deserialization. So that was a few code examples of the type of thing that can happen with insecure deserialization in .NET. And as I said before, there are links under this video to the source code if you want to try these projects yourself. In the next and final part of our presentation on insecure deserialization, we're going to look at ways you can protect yourself, general rules you can apply to reduce the risks of insecure deserialization impacting your software systems. So I hope you've found this video useful, and we'll see you in the next part.